Okay. So the question is like this. Right limb of a The right limb of a simple U-tube manometer containing mercury is open to the atmosphere, while the left limb is connected to a pipe in which a fluid of specific gravity 0.9 is flowing. The center of the pipe is 12 centimeter below the level of the mercury in the right limb. Find the pressure of the fluid in the pipe if the difference of mercury level in the two limbs is 20 centimeter. Therefore, there is a U-tube manometer which is connected to a pipe. Then U-tube manometer, right? So there is a fluid which is flowing through the pipe. This is the pipe. This is the pipe through this pipe there is a fluid flowing. Okay, and this is the level of the mercury. Okay, as I have told, the manometric liquid level. Okay, done. So this is applying a pressure on this. This fluid is applying a pressure. Therefore, there is a fall over here. There is a rise over here. Okay, remember this. And this is the level. Datum line. Okay, this is the datum line. Now, thing is that whenever the fluid applies the pressure on this, the manometric liquid will rise in this. Remember this point. Okay, which is the H1? Which is H1? And which is H2? Anyone? This is H1. This is H2. The height of the the rise of the manometric liquid above the datum line is H2, and rise the lighter liquid, the lighter fluid height is the distance is H1. Okay, therefore this is H1 and H2. Okay, so what is telling that there is a right limb of a simple U-tube manometer. Right limb means this one. This is right. This is left. The right limb of a U-tube manometer is containing mercury. This is having mercury, which is open to the atmosphere. This is open to the atmosphere. Okay. While the left limb is connected to a pipe. This left limb is connected to a pipe in which a fluid of specific gravity 0.9 is flowing. Okay, I'm not saying that it is the water. Okay, I'm saying that there is a fluid which is flowing through the pipe, which is having specific gravity as 0.9. Okay, done. The center of the pipe is 12 centimeter below the level of mercury. What is trying to say is this is the center of the pipe. Okay, from here the level of the mercury, this one on the right limb. The center of the pipe is 12 centimeter below the level of the mercury in the right limb. Where is the right limb? This one. The level of mercury is here. From there 12 centimeter below we are having the center of the pipe. Okay, done. Find the pressure of the fluid in the pipe if the difference of mercury level, which is the difference of the mercury level. This is the point where there is the interface between the liquid and the mercury, and this is the point where it is getting in the right limb. So the levels from this level to this level, it is 20 centimeter. Okay, any doubts? Any doubt in the question?
So explain the diagram once again.
Any doubt in the question?
Sir, diagram.
Can you repeat once again, sir?
Okay. So this is the thing. See here. So what it's trying to say is it is containing mercury. This is black color is what? This is completely mercury. Hg. Okay. And it is open to the atmosphere. And while the left limb is connected to a pipe which is a fluid having specific gravity of 0.9. This is the left limb, which is having a fluid which is having a specific gravity of 0.9. The center of the pipe is this one. Center of the pipe is 12 centimeter below the level of the mercury in the right limb. Find the pressure of the fluid in the pipe if the difference of mercury levels. This is the mercury level and this is one more mercury level. The difference between these two mercury levels is 20 centimeters. So what you have to find out? You have to find the pressure. How you will find out the pressure? Anyone? Which is H1 and which is H2? Which is H1, which is H2?
Sir, 20 centimeters H1.
Which is H1, which is H2?
Left one H1 and right one
H2 is 20 centimeter. Good. H1?
20 minus 12.
20 minus 12.
Very good. 20 minus 12 is H2. H1, sorry. H1 is 20 minus 12. How much it is? 8 centimeter. Okay.
centimeter.
This is H2 is 20 centimeter. So just you should remember which is H1 and which is H2. Based on that only you can find out. Now what formula I have to use? P equal to rho 2 GH2 minus rho 1 GH1. This is the formula for calculating the pressure inside the pipe when the fluid is at above the atmospheric pressure, whenever we are going to measure the gauge pressure. Okay, what is rho 2 here? What is rho 2? What is rho 2?
Mercury.
Rho 2 is the density of the fluid which is in the right limb or manometric liquid, that is 13.6 into, sorry, 13,600, not 13.6. Or we can write it like this: 13.6 into 1000 into 9.81 into H1. That is how much? 0.8 or 0.08?
0.8.
0.08 meter, right? 0.08 meter is the answer or no? Convert that in from meter to centimeter to meter. How much it will be? 0.08 meter minus what is rho 1? 1000 into 9.81 into what is the what is H1 now? H1 is, sorry, here it will be H2, 20 centimeter. That is 0.2 meter. I'll write it again. See here. So you understood the problem, is what he is trying to say. So I have written it in the this one. So what is given? The specific gravity of the fluid which is flowing through the pipe is given, that is 0.9. The density of that fluid is 900 kg per meter cube. The specific gravity of mercury is 13.6. The density of the mercury is 13,600 kg per meter cube. Kg per meter cube. Then difference of mercury level is H2, that is 0.2 meter. And the height of fluid from AA is H1, that is 20 minus 12, 8 centimeter, 0.08 meter. Okay. What is there? Let P, we have to find the pressure P, which is given by pressure of the fluid, and equating the pressure above AA, that is the datum line. So this is the formula. This is the left limb, this is the right limb. So P equal to rho 1 G1 H1 minus, sorry, this one. This will go out this side. So it will be rho 2 GH2 minus rho 1 GH1. So I have got this. Okay. So P plus 900 into 9.81. That is 900 is the specific gravity. 9.81 is G. H1 is 0.08. Equal to 13.6 into 9.81 into 0.2. Then the answer for this one will be 25977 Newton per meter square equal to 2.597 Newton per centimeter square. Can anyone tell me how many of you got the same answer? Am I right? Okay, fine. So this is the answer. This is the pressure which is there in the fluid in terms of Newton per centimeter square. Okay. The next problem you have to do now and tell me the answer. The problem is that a simple U-tube manometer containing mercury is connected to a pipe in which a fluid of specific gravity pointed is there and having vacuum pressure is flowing through the pipe. Okay, that's the vacuum pressure. The other end of the manometer is open to the atmosphere. Find the vacuum pressure in a pipe if the difference in mercury levels in the two limbs is 40 centimeter and the height of the fluid in the left from the center of the pipe is 15 centimeter below. So this is the reason. What is the question here? That is, it is vacuum pressure. If there is a vacuum pressure, what will happen? there will be a fall in the mercury in the right limb, okay, and there will be a rise in the left limb, because whatever force is there, there is no pressure. No pressure is below atmospheric. What will happen? The water is sucked in. Therefore, the manometer also will be sucked in the through the pipe. So water is getting inside this. So the level of mercury is rising in this. So which one is H2 and which two? This is H1, 15 centimeter, and H2 is 40 centimeter. So find the vacuum pressure in the pipe if the difference of mercury levels. Where is the mercury level? This is the mercury level, and this is the mercury level. Is 40 centimeter. Is 40 centimeter, and the height of the fluid in the left from the center of the pipe. From this center of the pipe, the height of the fluid is 15 centimeter. Okay, this is 40 and 15 centimeter. Now calculate the answer for this. I have told you the formula before. What is the answer?
So minus 54,543.6 Newton per meter square.
For your sake, I'll write the formula. Rho 2 GH2 plus rho 1 GH1 plus P equal to 0. Tell me the answer. You have to calculate P. What is the answer? Anyone? What is H1?
15.
What is H1 here?
15 centimeter.
What is H1?
15 centimeter. 0.15 meter. 0.15 meter, sir.
What is H1? Fast.
15 centimeter.
H1 is 15 centimeter, right? H2 is
Yes,
40
sir.
centimeter, right?
Yes, sir.
So can you calculate what is rho 2? This is mercury. 13,600 or 13.6 into 9.81 into H2 is 40 centimeter. You can write it as 40 into 10 raised to minus 2 meter. Then equal to, plus rho 1 GH1. Rho 1 is 1000 into 9.81 into H1. H1 is 15 into 10 raised to minus 2 equal to minus P we will write. Okay. So whenever you get the answer, it will be should be negative. Negative answer will come. Tell me
Yes,
fast.
sir.
What is the answer?
Minus
Minus
154.86.
54,543.
Any one of you? The answer which I have got is minus 5.454 Newton per centimeter square. Minus 5.454 Newton per centimeter square. Wait a second.
So minus
What's the answer?
minus 1524.86.
No, wrong.
minus 5.453.6.
Minus 4.54544.
Yes, sir.
Into
10 is to Newton.
convert that into Newton per centimeter square. Am I audible to everyone? Okay, I'll try to solve this here. Listen. Okay. So the answer will be minus 5.454 Newton per
Centimeter square.
Okay, this is the
Convertible
answer.
meter square.
You see, you will get the answer in Newton per meter square, right?
Yes, sir.
Newton per meter square. Okay, just you have to convert that into Newton per centimeter square.
Yes, sir.
Okay. Okay, ये हो गया. Next problem. See, why these two problems are basic. There is one more problem which is difficult, more than difficult than this. Okay, it will take time. So that's why I'm telling you to practice this first. You understand this problem first. Then only you can understand those. Okay, is it fine? Is this problem fine? Shall I go to the next problem, or shall I explain it again for you?
Explain once.
Sir, explain one second. Explain.
Okay. See here. Listen. Which one? Both the
First one, sir.
first one. Okay. There are two limbs. I have told you now. There are two limbs. One is the right limb. Another one is the left limb. Right. There are two limbs. One is right limb, left limb, and right limb. Remember this. Okay. This is the water or the fluid which is flowing through a pipe. And I want to measure the pressure at this point or in this pipe, right? So I'll connect this pipe with the YouTube manometer. Okay, in this YouTube manometer, there is one more liquid called as manometric liquid. Okay, that manometric liquid is having more specific gravity compared to the liquid which is there in the fluid. There in the pipe. It is having more specific gravity compared to the fluid which is there in this pipe. Okay, this is the concept of YouTube manometer. Okay, so he has told to calculate the gauge pressure which is above atmospheric pressure. So what he says is at the right limb of a simple YouTube manometer containing mercury, in this there is mercury, in this part there is mercury, in the right limb there is mercury which is open to the atmosphere. So I have told you that in a YouTube manometer, one end is connected to a pipe where you have to measure the pressure, and the other end is open to the atmosphere, right? Now, so this is open to the atmosphere means, see, written containing mercury is open to the atmosphere. It means that on the right side, this part is open to the atmosphere. So there is mercury here. Read the question and try to draw the diagram. Okay. It's not that for every problem they will be giving the diagram. They won't give the diagram. You have to draw it. You have to understand the problem and draw it. Okay. And while the left limb, which is there, this is the left limb, which is connected to a fluid. This is the left limb, na? This is the right limb. The left limb is connected to a pipe in which a fluid of specific gravity 0.9 is flowing. 0.9 is flowing. The center of the pipe, whatever the center of the pipe is, this is the pipe, and the center of the pipe is 12 centimeter below. From where? From the level of mercury. This is the level of mercury. In the right limb, it is 12 centimeter below the center of the pipe. The center of the pipe is 12 centimeter below. Okay, from the right side, from the right limb. Okay, find the pressure of the fluid in the pipe. Find the pressure of the fluid in the pipe. If the difference of mercury levels, in the two limbs is 20 centimeter. This is the point where mercury ends. See here, the water will enter like this, or sorry, the fluid which is there, it will enter and start creating a pressure on the mercury. The mercury will go up or rise. This is called as datum line. So this is the point where the mercury and the liquid will make an interface. Okay, and at this point it is open to the atmosphere, but at this point it is undergoing the pressure applied by the liquid which is flowing through the pipe. So this is the level of mercury. So what will be the level of mercury? 20 centimeter, right? 20 centimeter. So what you have to find out, you have to find the pressure inside the pipe. Okay, for that, this is the diagram. So this is the fluid which is having a specific gravity of 0.9. This is mercury. This is mercury, and this is the datum line. This is the level of mercury. This from this end to this end. This is the level of mercury. Okay. Now, so what? The center of the pipe. This is the center of the pipe. This is 12 centimeter below the level of the mercury in the right limb, and find the pressure of the fluid in the pipe if the difference of mercury level, this is the mercury level and this is the mercury level, so the difference is 20 centimeter. Now which is H1 and H2? Which is H1 and H2? H2 is 20 centimeter and H1 is this is H1, right? From this end to this end, this is H1. Okay, you can verify it in the derivation. You can check it in the derivation. Okay, in the last class which I have done. Okay, this is the difference, that is H1, 20 minus 12, 20 minus 12, that is 8 centimeter. This will be 0.08 meter and this will be 0.2 meter. Now what is the formula to calculate the pressure when in a U2 manometer which is above the atmospheric pressure? P equal to rho 2 GH2 minus rho 1 GH1. So substitute all the values and you'll get rho 2 is the density of mercury, rho 1 is the liquid which is flowing through the pipe. But he has not given the density. He has given specific gravity. You know how to calculate density using specific gravity. Density, specific gravity into 1000 will give the density of the fluid, that is 900 kg per meter cube. So this is 900, this is 900, 13.6, this is 13,600, this is, and this is 900. Okay, understood the concept at least?
Yes, sir.
Okay, now, so I have calculated it over here. So specific gravity is 13.6 and the specific gravity of liquid which is flowing through the pipe. This is in pipe. This is in U-tube. Okay, U-tube manometer, manometric liquid. Okay, both the specific the specific gravity of liquid which is there in the manometric tube is greater than the specific gravity of the fluid flowing through the pipe. Okay, so calculate its density multiplied with 1000, multiplied 1000. So you'll get 13,600, 900. Then the difference of mercury level is H2, 20 centimeter. We have got height of liquid from H1 is 20 minus 12 is 8 centimeter, 0.08. Equate the equation. Please mute whoever it is. P plus rho 1 GH1 equal to rho 2 GH2. That is the equation. You can check it from derivation of U2 manometer for gauge pressure. Okay. Then what you will do, you will just substitute the values. Then you have got the answer as 2.597 Newton per centimeter square. Okay. Any doubts? Shall I repeat the second problem also, or is it fine?
Repeat, sir.
Is it
Second
fine,
problem.
Repeat,
Second
sir.
problem also. Okay. So in this, the only point is that we have to measure the vacuum pressure. So the vacuum pressure जब यहाँ पे बढ़ेगा ना, तो क्या होगा कि when the pressure increases, the fluid will start applying a pressure on the manometric liquid. It will start dripping down, and there will be a rise here. But whenever there is a vacuum pressure, water will be sucked in, and because of which there is a dip in the mercury level, and there is a rise in the mercury level in the left limb. Okay, so therefore this will become H2 and this will become H1. It is there in the derivation which I have done in the previous class. So this is H1, this is H2. Now the at this end, on the left end, the pressures will be acting are which one? P plus rho 1 GH1 plus rho 2 GH2. On the right limb, what are the pressures acting? On the right limb, which pressure is acting?
Zero, sir. Zero.
Zero.
Atmospheric. Zero.
Atmospheric pressure is acting, therefore it is 0. And if it would have been risen up, see, अगर ये इस datum line के ऊपर चला गया होता, तो I would have got something na H2. That would have been my rho GH2. Okay, but here there is no rise, and above which there is atmospheric pressure acting. Therefore, this is equal to 0. So by calculating or by doing all this, we'll get P equal to minus something of the answer. So what is the answer which you have got? I got minus 5.45 Newton per centimeter square. This is the answer which I get. You have to solve these problems and keep it with you. I may ask it any point of time. Okay. Any doubts?
No, sir.
Okay. So shall we go for the next problem, which is a bit tough one?